Hello and welcome everybody to today's webinar. My name is Markus Major. I'm part of MVTec's marketing team and today I'm very happy to be your host for this webinar. Let's start with why this topic today, AI inspection, is very important. And we at MVTec did some research and we found out that unplanned downtime costs large companies around 11% of their revenue. At the same time, many inspections are still done by hand. But machine vision, don't worry, can help there. It can improve defect detection up to 30% compared to manual inspection. So the question is not if, but how to implement AI inspection into your production processes. Sounds quite interesting. Before we start, I got 3 informational points for you. So first of all, this session is being recorded. You get the recording, of course, directly in the next few days after the webinar. Also, you can ask questions. So if you have questions, don't hesitate, write them in the chat during Ulf is speaking today, and he will answer your questions personally after the webinar. And last but not least, we plan to do many more webinars and we need your opinion, your feedback on that. What can we improve? What should we keep? So please provide your feedback. There will be a survey after the webinar, so we would like to appreciate your opinion on that. That's it from my side. It's time for your speaker today, and your speaker is our product manager MERLIC, Ulf Schulmeyer. Ulf, please join me on stage.
Hello, Markus.
Hi, Ulf.
Hello, everyone. Hi.
You doing good?
Yes, sure.
Yeah, you've just came back from another trade show. What are your impressions? What do you see on new developments?
Well, there are new buzzwords appearing there. It's agentic AI, it's physical AI, and maybe this could be interesting topics for more webinars from our side.
Yeah, it's a lot about AI. Also today is about AI.
Yeah, sure.
AI inspection. And did you also hear from customers, from visitors?
Yes. The companies visiting us at our booth, they want to know everything about these new capabilities and they want to build their own know-how. And that's why we're here. So
it's quite easy, right?
Yeah, that's it. That's my part, to show how easy it is.
Wonderful. Then I would say the stage is yours. Enjoy the webinar. See you later and thank you very much.
Thank you. Okay, thank you, Markus. So let's have a look what we will learn today. We will start with a short introduction of MVTec and its portfolio. After that, I will show you the required workflows and we start to connect and to configure the camera. And then it gets practical. We capture images with MERLIC, switch over to the deep learning tool and prepare the model. With this model, we then create a machine vision application and finally, to perform a live inspection, we will build a nice front end. At the end, we will briefly talk about industrial communication to help us forward the results. Sounds good? So let's go. MVTec is based in Munich, Germany. We have more than 28 years of expertise in machine vision. We employ more than 300 people. Half of them are working in our product development and research department. Our Halcon software features over 2,100 machine vision operators. And we successfully implemented our first deep learning method back in 2016. We have a large network of technology partners and integration partners. And here's our portfolio. MVTec Halcon is our powerful, comprehensive software library for machine vision. It includes an integrated development environment and offers over 1,000 examples from all kinds of industries. It is the well-known gold standard in machine vision, and it is used by over 4,000 customers worldwide. Based on Halcon, we offer MVTec MERLIC as a user-friendly, no-code machine vision software that enables the easy creation of image processing applications without programming. And the best part, AI is already included and you can test it 45 days for free. With our deep learning tool, You can label images and train your models. You can download it for free, and it will allow you to check if you can create robust AI models with your existing images. And as you can see here, MVTec's products are working seamlessly together. MERLIC's existing tool library can be extended with customized, user-defined tools to suit any additional needs. And MERLIC provides common industrial communication standards and is extendable with customized plugins to integrate MERLIC in your application. Talking about AI and deep learning. Here you can see a comparison of classic machine vision and machine vision with deep learning. The biggest difference is feature extraction. With conventional methods, the image processing engineer has to decide which features to look for to recognize a specific object in an image. Furthermore, the right set of features must be selected for each class. And this quickly becomes tedious as the number of possible classes grows. Which features should be searched for? Color information, edges, textures? With deep learning, the algorithm is simply told what to look for in relation to each specific class. By analyzing sample images, it automatically identifies the most prominent and informative features for each class and each object. And the algorithm does not get tired. It doesn't need food and it doesn't go on vacation. It makes consistent decisions whether it's image number 1 or image number 10,000. And here you can see some of the deep learning methods MERLIC provides in combination with the deep learning tool. And we'll take a closer look at a few of them today. Image classification assigns objects to a specific class based on predefined characteristics. This technology is used, for example, for inspection tasks in quality control. Anomaly detection enables automated surface inspection, for example, for the detection and segmentation of defects. The technology is able to locate deviations, for example, defects of any kind. Only images of workpieces without defects are needed to train the model, so the images do not need to be labeled. Object detection locates trained object classes and identifies them with a bounding box, for example, for pick-and-place applications. Segmentation assigns a class to each pixel in the image, or objects can be assigned to different classes with pixel-level precision. This is particularly important for overlapping objects and regions. Consider its use in medicine for tumor detection. When text is recognized using deep learning, it is called deep OCR. This new technology brings industrial image processing a step closer to human reading. Compared to classic OCR, optical character recognition, deep OCR can locate characters much more robustly, even regardless of their orientation, font, and polarity. The ability to automatically group characters enables the identification of entire words. And deep learning is also a great help when counting objects, as robust results can be achieved very quickly with minimal training. With MVTec, you get the entire workflow from a single source. Data management, labeling, training, and inference. Everything is designed to work seamlessly together, so customers don't have to deal with compatibility issues. Our research department works closely with our customers, ensuring we provide the latest technologies in the field. All models provided by MVTec are pre-trained on a very large and diverse internal data set. And this data set has been carefully compiled and curated so that the resulting networks are excellent starting points for fine-tuning to industrial applications. And we as MVTec also place great emphasis on the legal compliance of our technologies. You and your customers can absolutely be certain that no images from dubious sources were used. Therefore, you do not run in any risk of patent infringement or copyright violations. And please note that many freely available open source deep learning models are not licensed for commercial use. But now let's talk about workflows. Here you can see MERLIC's straightforward standard configuration workflow. And all starts with using the integrated image source manager for configuring cameras or other image sources or image files, including regions of interest, exposure time, and trigger mode. Then you create your machine vision application within MERLIC Creator. Here you can find predefined tools and you define the logic of your application. Then continue with the front-end designer for statistics, showing values and different user levels. Design your interface for the user for the machine. Show it locally or remotely. And then switch from the development to the runtime environment. With the RTE setup, you integrate MERLIC into your process. Here you manage recipes, interfaces, and communication protocols. And as a last step, MERLIC RTE is used to execute the MV app and the front end. And this slide here shows the interaction between MERLIC and the deep learning tool. While image acquisition and pre-processing are handled in MERLIC, the images are managed, labeled, and the model is trained and evaluated in the deep learning tool. Inference then is performed using MERLIC. But now let's start with our first deep learning method I want to show you today. Let's start with classification. With classification, you can solve different kinds of tasks. Here you can see a simple classification problem. We just want to classify the different types of pills. The shape and possibly color of the pills is very different, and thus the features are vastly different and the problem becomes easy. And here is a complex classification problem. We want to classify different defects like cracks or contamination on different pills. Since it does not matter what the pill is, but only the defect type, the network needs to learn the overarching features of a defect irrespective of pill type. You can certainly imagine that the number of images needed for training to create a robust model depends on the use case. At MVTec, people often ask us about the minimum amount of data or labels needed for deep learning. The honest answer here, unfortunately, is it depends. It depends on the content of the images, on the complexity of the problem, how close the class boundaries are, and many, many more. So, as a rule of thumb, we typically recommend a minimum of 100 up to 300 instances per class. But this number can vary. Depending on your task, this would be 100 images per class for classification, but fewer images for object detection with multiple instances per image. However, the variance here is large and you may need much more for your problem. But as mentioned before, MVTec generally reduces the amount of labels needed drastically by delivering pre-trained models. And today we want to look at the classification of almonds and hazelnuts. And as you saw before in our workflow slide, we start with image acquisition and pre-processing in MERLIC. Here you can see a screenshot of the image source manager of MERLIC, where you can configure cameras, define folders of already acquired images and parameters of image acquisition like exposure time, gain or trigger. And with the Image Source Manager, you can acquire images. But I will show you this directly in MERLIC. Okay, now let's acquire some images with MERLIC. I start MERLIC here, and this is the version 2603, which was released in March 2026. And as you can see here, MERLIC always starts with a welcome dialog. And in this welcome dialog, you have access to your recent MERLIC Vision applications, or you can choose an example here, different kind of use cases. Those examples are very good starting points if you're unfamiliar with MERLIC. Then there's a help section here where you can find links to our MVTec Academy, our self-learning platform with different kind of video courses about Helken, MERLIC and the deep learning tool. You can find a link to our What's New section if you're familiar with an older version of MERLIC. Here you can find information about the new features of this current version. Then you have a link to our detailed documentation of MERLIC, and of course there are some tutorial videos how to work with MERLIC. We do not need it, so I can close it. And here you can see the graphical user interface of the MERLIC component Creator, MERLIC Creator. So here in the upper left section you find the tool flow. There's already a tool selected, and below of this tool flow you can find the tool library with all the predefined tools. It starts with acquisition. You can choose calibration tools if you need to calibrate your camera. There are some pre-processing methods like alignment or cropping or resizing your images. And then, of course, the probably most important part of MERLIC, the processing tools with checking, measuring, counting, deep learning methods, and so on. In the middle of the screen you can see the processed image, and right of it you can see the documentation to the selected tool. And as you can see here, there is a little warning sign, and it tells us that there is no image source configuration done. So we started here, and for this, in the background, another component of MERLIC is started. This component is called the MERLIC Runtime Environment Setup. And as you can see here, there are 4 tabs in the MERLIC Runtime Environment Setup. It's the Image Source tab, which we will have a closer look right away. Then there is the Communication tab, where you can define your industrial communication with different kind of communication protocols like OPC UA, MQTT, or Siemens S7, just for instance. Then there is a Recipe tab, where you can manage and control your recipes, and if needed, you can define an I/O communication. But now let's have a look at the image sources. We create a configuration. A configuration is like a container where you can add different cameras or different folders with pre-acquired images. I call it webinar, and I start to create it. I add an image source. It's called webinar camera. And now I want to plug it in and reconnect. And now let's have a look when it's available. Again. And here it is. So I create this image source, and now a very important step is to activate it, and I can start acquiring images. So you can see here we have a live image. In the middle is the preview, and on the right side of it you can access the parameters of this camera. There are 2 tabs. We have the easy params, where you can change the exposure time, the gain or the trigger, but of course you have access to all parameters this camera offers. But I think the image is quite okay. So now I can start acquiring images, and for this I use this Save Image button. I want to save those images in a specific folder. It's called New Images Elements, and I give them the name Elements. Okay, save, and here we got a green message, and it was successful. And now, as I told you, we do not need just one image, but more images. And for this, I can add more elements, or I can remove some elements from this table, or I can just switch a little bit from this configuration, and I save another image. Another one. And again. And I have to do this multiple times with the almonds and of course with our hazelnuts. And after that, I want to show you another step. This is an optional step. You do not need it necessarily. We can add another image source. But for this, I want to not use another camera, but an image directory, which I have chosen here. So, and I give this the name Elements. I create this. And now I can check my acquired images. All right, so let's go back to MERLIC Creator, and as you can see here, the little yellow icon has disappeared, and I can switch to the live image, or I can see my acquired images. So this was very fast. Now we have our images, and with these images we go to the deep learning tool and we will train our model. After acquiring images with MERLIC, we switch to the deep learning tool, where we start with the data management. Labeling training data is the first crucial step towards any deep learning application. The quality of this labeled data plays a major role when it comes to the application's performance, accuracy, and robustness. With the deep learning tool, you can easily label your data thanks to the intuitive user interface, without any programming knowledge. To achieve the best possible results, there are a few points to consider in this context. Label your data consistently. Label your data thoroughly. Check for strong class imbalances. Pre-process your images such that the relevant features remain. Use appropriate data augmentation techniques when necessary. And look out for bias in your dataset with tools like the heat map. Unfortunately, I cannot elaborate on these points. In this context, I would like to refer you to the MVTec Academy. Our free self-learning platform offers a wide variety of courses on our products and on deep learning topics such as classification. But now let's have a look into the deep learning tool. Okay, after acquiring the images with MERLIC, we switch to the deep learning tool. I started here right away, and it is the version 2603 of the deep learning tool. We have released it in March 2026. So in the start section of the deep learning tool, it's the project tab. You can see the possibility to start with a new project or open an existing project. You have an overview of recent projects or an overview of the example projects which are delivered with the deep learning tool. So we start here, a new project, and here you can see the different deep learning methods the deep learning tool provides. It's classification, it's anomaly detection, two kinds of object detection, semantic segmentation, instant segmentation, and deep OCR. Today we want to use the classification. We give our project a nice name, webinar. We are choosing an appropriate folder for that. And then create our project. In the Gallery tab, you have the possibility to add single images or complete folders of images. And we prepared two folders of images, one with almonds, one with hazelnuts. So we are checking where we have them and add the folder. And as you can see, the folder name is used as class name. And while importing the images are already labeled. So this is very handy. And as you can see here, all the yellow marked images are the almonds. So now let's add the other folder, the hazelnut folder. The class name is OK, imported, and now you can see the blue mark, and these are all our hazelnut images. In the next tab, this is the image tab, you have the possibility to check all your images in detail. And if needed, you can delete single images if you find them not so appropriate to train your model. The Review tab gives you an overview of all your images and all your labeled images. And then there is a very important step in creating a model. Now we have to create a split. And in this step, we split the annotated data into three sections: into the training, into the validation, and into the test section. The training section is used to optimize the weights of the deep learning network. The validation section is used to track the performance of the model. And with the images in the training sections, we do not in the test section, we do not train the model. They are just used to check the performance of the model and the ability of the model. So we are using these predefined options. You see here we have in total 299 images, 209 training images, 45 validation images, and 45 test images. So you can change the split mapping if needed, if you find to a later point in the training mode that this is not appropriate, but I think here we can leave it as it is. And then we switch to the training section. Here we start to create the model. We have to save our changes. And then you have different kind of options here. You can change the pre-trained model, you can change the image sizes, and you can change the number of epochs and number of iterations. For further information about all these options, I recommend to consult the documentation of the deep learning tool or to visit the MVTec Academy. There are different kind of self-learning courses with all information which might be needed to create powerful deep learning models. So this step is a little bit more time consuming. So I want to use already the pre-trained model I prepared it here. So you can see these are our images. The review and the split is all the same as I showed before. And here we are with the results. There are two result tables where you can find the results of all the training activity. And the next step is the evaluation. And here, this is what we want to see. It's 100% accuracy of the training model. So this indicates that it will work very well in our machine vision application in the end in MERLIC. And the last step is to export the model. And here you also have different kind of options. You can export it for optimized for inference or optimized for AI square interfaces and so on. And just using a good name and then export the model. And when you have the model, you switch back to MERLIC. So after creating the deep learning model, we switch back in MERLIC for the inference. Now we will create our MERLIC vision application and design our front end. Okay, now we have the trained model. And with this model, we switch back to MERLIC for the inference. And you can see here we have the same setup as before. We have our camera with a live image and our elements here. And now we search for the processing tool as a deep learning method, classify image, and just add it here per drag and drop. And now you can see here, this is the input image, but there is no output, no result. And for this, we have to define the classifier file. And the classifier file is the model we just created in the deep learning tool. So I've prepared that for you again. It is here on my hard drive. Deep learning models. All right, and yes, and you can see here, the result is almonds. So this works quite well. And normally now you would design a front end for controlling the processes on the machine. And here you can see another component of MERLIC is the MERLIC designer. We start with a picture box, which we place in the background, just to have a nice background with your company logo or whatever you need. Then we need an image display, just per drag and drop. Scale it a little bit. And then we have to connect it to a specific tool. In this case, it's the image source, and the connected parameter is image. Then I want to add an execution control. We place it in this corner. And then we need two labels. Here just a plain text to describe what we can see later in the front end, and a label, and this label is the result. We connect it to the tool classify image, and in this we use the parameter detected classes. All right, looks fine. So I launch the front end now. Okay, here it is. And as you can see here, we have a single execution, a continuous run, and we have a result. And now we switch the things we have to examine. And now, as you can see here, the result is hazelnuts. So it works quite well. Okay, so this was classification. And now I want to show you another method, the method of anomaly detection. But for this, we switch back to our slides. Let's check some screws for anomalies. The method is called anomaly detection in the global context. Here you can see the screws with different kind of defects. For example, a dent here or a missing screw tip here. Anomaly detection is your preferred method if you do not have a lot of images with defects and you do not know exactly what kind of defects will occur in your production line. For this inspection, we don't capture the images in the image source manager as we have seen before in the classification task, but we instead create a workflow for image acquisition in MERLIC. We sequence individual pre-processing steps. First, alignment, and alignment ensures that we always see the screws in the same position in the image, regardless of how the image was captured. We base this alignment on specific features in the image. After alignment, we perform cropping. Here we reduce the image size to the area actually being examined. And finally, the captured image is written to the hard drive. And with the captured images, we switch to the deep learning tool and train the model. Same process as you saw before. And finally, we add the inspection method at the end of our workflow in the MERLIC creator. And the result is that we can see a heat map which point out possible errors. Step 4 is to build a front end in the same way I showed you before. So as you can see, these steps are very simple and you can get a result very quickly. Of course, with this method, global context anomaly detection, you can set individual thresholds to determine exactly when a defect actually exists. Okay, so now we have images, we have the methods for examining these images, and we obtain results. But what happens to these results? To answer this, let's finally take a look at the general architecture of the MERLIC image processing system. And here you can see a simplified view of a typical production environment and how communication works within it. On the left side, we see the development environment. We looked at this area today. We developed and tested a machine vision solution and configured a runtime environment using MERLIC Creator. MERLIC can communicate with PLCs to exchange data. MERLIC processes an image and determines, for example, whether a product contains a defect. And this inspection result is sent via a signal to the PLC, which can then trigger appropriate reactions, for example, reject a part. And the whole process can be visualized and supervised via higher level systems such as an HMI or SCADA. But that's a bigger topic and we will look at it in another webinar. All right, so that's all from my side for today. As Marcus mentioned before, please contact me if you have further questions. And please use the survey to send us your feedback. You can also follow me on LinkedIn and perhaps I'll be at a trade fair near you soon. So all the best from my side and see you.